Hi guys! Welcome to Engineered Math Channels. Sa araw na ito, ang ating tatalakayin ay ang gamma, beta, and other special functions. So we are now proceed first to gamma functions. Gamma function. In mathematics, the gamma function represented by R. The capital letter gamma from the Greek alphabet is one commonly used extension of the factorial function to complex numbers. The gamma function is defined for all complex numbers except the non-positive integers. For any positive integer n, we have a formula of gamma of n equals n minus 1 factorial. Let's have an example. We have gamma of 3 is equals to n minus 1 factorial. All we need to do is to substitute the 3 in the letter n. 3 minus 1 factorial. So we have now 2 factorial. Let's proceed to the other one. Derived by Daniel Bernoulli for complex numbers with the positive real part. The gamma function is defined via a convergent improper integral. We have a formula of gamma of z is equal to integral from 0 to infinity x raised to z minus 1 e raised to negative x dx. And gamma of z or n greater than 0. The gamma function then is defined as the analytic continuation of this integral function to a meromorphic function that is holomorphic in the whole complex plane except 0 and the negative integers where the function has simple poles. The gamma function has no zeros, so the reciprocal gamma function 1 over gamma of z is an entire function. In fact, the gamma function corresponds to the Mellin transform of the negative exponential function. We have a formula of gamma of z is equals to Mellin of e raised to negative x z. So let's have an example. So we are going to prove now we're going to prove that gamma function has no zeros. 0 factorial is equal to gamma of 0 plus 1 equals integral of 0 to negative x raised to n e raised to x dx. So we have now 0 factorial is equal to gamma of 1 integral from 0 to infinity x raised to n e raised to negative x dx. So we're going to substitute this one here in letter N. So we have integral from 0 to infinity x raised to 0 e negative x dx. So makakancel na ito dahil 0. Meron na tayong integral from 0 to infinity e raised to negative x dx. So let's integrate. Let u equals to e negative x du equals to negative e negative x. So we have now negative e negative x raised to negative x integral from 0 to infinity. So para maging positive to, kailangan nating ibaba itong e na to sa baba. We have now 1 over e raised to x integral from 0 to infinity. So we get infinity times 1 is equal to 0 minus 0 times e raised to x is 1. Negative times negative 1 is equal to 1. So now, we prove that gamma function has no zeros. The next slide is representing by Mr. Junel.
So now we are continue the discussion. The notation gamma of z is due to the legendre. 1 if the real part of the complex number z is strictly positive gamma of z or n is greater than 0, then the integral which have the formula of gamma of z is equals to the integral from 0 to infinity x raised to z minus 1 e raised to negative x dx. Converge absolutely and is known as the Euler integral. Of the second kind, Euler's integral, the first kind, is the beta functions. Using integration by parts, one sees that the gamma of z plus 1 is equals to the integral from 0 to infinity x raised to z e raised to negative x dx. So dito, nag-integration by part siya. So hindi shortcut. So ang magiging nangyayari dyan is dito negative x raised to z e negative x open close braces and from 0 to infinity plus integral 0 from infinity zx raised to z minus 1 e minus negative x dx. So, dito is pinalitan niya yung value ng infinity which is yung x. Kaya ito maging x. So which is limit of x is going to infinity. So negative x raised to c e minus x open close parenthesis minus negative 0 z e raised to negative 0 plus z is integral of 0 from infinity x raised to z negative 1 e raised to negative x dx. So recognize that negative x raised to z e raised to negative x will become will become 0. So this maka-cancel na yan, so 0 na yan. Ang matitira is ito yung z integral from 0 to infinity x raised to z minus 1 e raised to negative x dx. So continue. So continuing. So z integral of 0 from 0 to infinity x raised to z minus 1 ex e raised to negative x dx. So nakikita natin dito na magkamukha ang gamma z natin is equals to this part. So we are going to palitan na lang to para mas madali. So makakuha natin ang z gamma of z. So ang sagot dito sa may gamma of z plus 1 is equals to z gamma of z. So para mas madali nating maintindihan, we are going to explain that in this white sheet. So gagamit tayo ng gamma of n plus 1. Gamma of n plus 1. Which dun sa may PowerPoint natin, ang ginamit niya is c. So tayo naman is n. So to prove natin na dapat ang magiging sagot nito is n gamma of n. Same with this. Kasi dito hindi niya pinakita yung ano. So Rn plus 1 equals to the, so meron tayong formula. So infinite from 0 sa infinite. So e okay minus x xn ay xn plus 1 to minus 1 dx where n 0. So from this, we are going to substitute n by this gamma of n plus 1. So magiging integral from 0 to infinity e raised to negative x. So substitute natin yung n doon sa may gamma na nakapaloob. So n plus 1 minus 1 dx. So ito makakancel na yan. Magiging 0. So n na lang matitira. So magiging integral from 0 to infinity. Infinity yan. Negative x. So n x. So x n dx. So we are now going to integrate. So this from this equation, we are integrate that So we see that we are ito yung binubuo ng algebraic terms and exponential terms. So we use the du, let u, and then let b, let dv. So let u, ang u natin dyan ay, so ang u natin, ayun ba? Ano ba naman? So let u. So algebraic term u. So xn. So let du. Ano? Is n x of n. X of n minus 1. So dv, so integral of dv of e. So b is equals to the negative x, negative e raised to negative x. So Rn plus 1 is equals to the, so we are now integrating that uv. So what is u? X n. Then what is b? Negative e with negative x. So open close parentheses. So this is infinite. This is 0. So we are now going to so yung infinite, babaguhin natin yan. Let's say gagawin natin let b. So ang lalagay natin dito is limit of b going to the infinity. Since so we are here plus integral of from 0 to infinity, and then value of du and then dv. So n x n minus 1, then e raised to negative x dx x dx. So dito na tayo. So we are going to limit this as, para maging positive tong negative exponential ng e. So we are going to 1 over e raised to x time is negative x and this is infinite 0. So dito meron pa dito limit pa dito. So limit of b infinite. So plus, so ilalabas natin to. Ilalabas natin yung dito sa kabila, ilalabas natin yung n. So 0 from infinite plus x n minus 1 e minus x dx. So we are going to solve that. So itong let b natin. So we are substituting this 1 dx. So we're dx times natin dito sa negative x raised to infinity so so dito raised to n let b. So dito let b tayo. So dito kung i-substitute natin to, para mas malinaw, plus n for 0 from 0 to infinity x n minus 1 e plus x dx. So dito pala mali. So mali ito. So let n tayo. So let b x. Okay. So if we are here, so dito na tayo. So 1 over e raised to infinity times the negative x n then plus so minus xn so minus so 1 over e raised to 0 plus n from 0 to infinity x n minus 1 e negative x dx. So where this 1 over e raised to the infinity, so this will become 0. Then this will become 1. So time is, so it will become 0. So we are now having n integral from 0 to infinity x is to n minus 1 e negative x dx where this formula x minus 1 raised to e raised to negative dx is equals to this formula. So dito nga lang is n, dito is dito nga lang is z, dito nga lang is n. So therefore, is equals to the n gamma of n. So we are now proved that the n plus 1, it is equals to, so gamma of n plus 1 is equals to the n gamma of n. So it's okay now. So next slide. So we can calculate gamma 1. So using this formula, so gamma 1 is equals to the gamma of from 0 to infinity x. So dito x raised to 1 minus 1 e raised to negative x dx. So mayayari dyan is negative e raised to negative x, open close braces, 0 from infinity. So limit of infinity is gagawin natin siyang variable of x. So limit of x to the infinity, negative e raised to negative x, open close, minus e minus 0. So therefore, this is negative e, negative x is equals to 0. Then this negative e raised to 0 is 1, negative 1. So therefore, 0 minus negative times negative 1 is equals to the 1. So given that gamma of 1 is equals to 1 and the gamma of n plus 1 is equals to n, gamma n. So gamma of n is equals to 1 times 2 times 3 and so on. Then n minus 1 is equals to the n minus 1 factorial. For all positive integers n, this can be seen as an examples as proof by inductions. They identify gamma of c is equals to r z plus 1 over z. Can use or yielding the same result. Analytic continuation can be used to uniquely extend the integral formulation for gamma x to meromorphic functions defined for our complex number z, except integers less than or equal to 0. It is this extended version that is commonly referred to as the gamma function. So dito guys, para mas lalo nating maintindihan, so let's say, barihin muna natin to. So let's say, given sa atin is gamma of 2. So ano yung ano niyan? So it is equals to the 1 factorial. So gamma of 3 will be 2 factorial. So gamma of 4, which is 3 factorial. So sa gamma functions in a whole number, kapag kukunin natin yung kanyang factorial, it is lesser than 1. So ayun lang. Then katulad dito, yung sinabi dito, formula is pagkuha ng factorial is n minus 1. So yan lang. So dito, magbibigay tayo example for this formula as gamma of z is equals to gamma of z plus 1 is equals to z. Over a gamma of z is equals to gamma of z plus 1 over z. So magbibigay tayo example yan. So now, bago tayo magbigay ng example for this formula, we are going to proceed this slide. So gamma functions table. So we are having a table this n when 0.1, the gamma of this is 9.5. 0.2, 4.59, 0.3, 2.99, 0.4, 2.22, and 0.5 is square root of pi. So given examples, gamma of 3.2 is equals to the gamma of 2.2. We are 2.2 plus 1. So we are going to sundan itong mga na dito sa taas yung formula. So 2.2 plus 1. 2.2 plus 1. Kasi nga, kung bakit naging 2.2 plus 1, di ba nga, kapag kukunin natin yung factorial niya, di ba, we are going to lesser than 1. So minus 1. So 3.2 minus 1 is 2.1 plus 1. Plus 1. So ayun. So 2.2 gamma of 2.2 is equals to gamma of 2.2 factorial. Where kung ita-type natin sa hindi naman kung sa may calculator, masabi natin na baka kung ita-type natin to sa calculator. So let's say 2.2 factorial ay 2.2. Math error. Kaya ang gagawin natin is mamanang-manoy natin. So 2.2 factorial, 2.2 gamma of 1.1 plus 1. Kaya naging 1.2 yun. May minus natin ng 1. So 1.2 plus 1. So 2.2 times 1.2 gamma of 1.2. So yung 1.2 na yun, nahatiin pa natin minus 1 ulit. So magiging 2.2 times 1.2 times gamma of 0.2 plus 1. So 0.2 na yun, ang value niya is 0.2 is 4.59. So 2.2 times 1.2 times 0.2 times 4.59. So we are going to have the answer. Get the answer. So 2.42352. The answer. So we are now having this formula. We're going to write this. So let's say RZ is equals to the gamma pala yun. Mali of Z plus 1. So Z. So eto. So magbibigay tayo ng example. Let's try about the negative 3 point something. Ba maganda? 3.2, no? Para mas maganda. So we are proceed this equation. So gagawin natin example natin na mas papadali natin. So 3.2 gawin na lang natin na, so let's say 3.2. So eto guys, etong formula na to, ginagamit lang to kapag let's say negative yung ating gamma. So let's say this. So R So let's say this are 3.2 plus 1 is 1 over 3.2. Kainit. Nakakantok. Is equals to the R minus 2.2 over gamma of 2.2 po yung mga gamma of 2.2 over negative 3.5. So under this, di ba babawasan siya? So magiging 1 over 3.2, then R ulit, negative 2.2, 2.2, then it is equals to the gamma of 1.2, negative 1.2, then 2.2. So ganun lang, ganito lang. So in para mapadali, so 1 over 3.2. So, di ba ito yung original term, ang original niyang value. So, magiging 2.2. So, magiging 1.2. Okay. Tapos, magiging 0.2. And then, times. So, ano ang value ng 0.2 natin? So, makikita natin dito, ang 0.2 natin is 4.59. So, 4.59. Okay. So, kapag sinolve natin yan, ang makukuha nating sagot is, so, using calculator, 2.2. Time is 4.59. So we are having is 2.71. So this will be the answer. Okay. This will be the answer. So we are back in this slide. So kailangan natin tandaan itong mga table na to para mas madali nating mahanap yung gamma functions. Let's say, ayun nga, yung mga gamma functions, tandaan din natin yung mga integral by parts. So, okay. So, we are now proceed the examples given by this gamma. So, proceed the example in this gamma. So, guys, so dito na tayo sa may mga example. So, mag-example tayo regarding to sa gamma function. So we have a formula of gamma of n plus 1 is equals to the n gamma of n is equals to the n factorial. So to determine, so let's say r to the fifth. So finding the factorial. So alam naman natin kapag hinahanap yung factorial is gagamit tayo ng formula which is n minus by 1 factorial. So magiging sagot niyan is 4 factorial. So ngayon kapag hanapin naman yung value niya. So gamma of 5 is equals. So we use the 5. So dito mali yung 5 kasi start tayo ng 4. So start tayo ng 4. Plus 1 4 plus 1, so it is equals to the n which is 4. So gamma of 4 where 4 is 3 plus 1 wherein this is 3 of 3. So parang sundan lang natin yung pattern niya. So di ba 4 ang una, 4? So tatimes na natin dito, open to. So 3 times 3. So di ba kapag kasinundan natin yung formula times 2 times by 1 times, so di ba 1 gamma of 1. So meron pa ditong 1. Kaya magta-times pa tayo ng 1. So magiging 4 times 3 times 2 times 1 times 1. So 4, 8, 12, 24. So 24. Ang sagot. So, ganun lang din sa ibang kung hinahanap yung factorial, minus 1. Then, kapag hahanapin yung value, susundan lang yung pattern na r is equals to n plus 1 is equals to n gamma of n. So, yun lang guys. So, for more example, will representing by Mr. Joshua Nepomuceno.
Let's have another example. We have gamma of 4.8 equals 4.8 times, maminusan lang natin ng mali. 3.8. Then times, maminusan lang natin ng 1. So 2.8 times minus 1 ulit, 1.8. Then times ulit, minus 1, 0.8. Then get the value of 0.8. 1.16. So times 1.16. Let's calculate. Let's use calculator. 3.8 times 2.8 times 1.8 times 0.8 times 1.16. We get 17.77. 17.77. And this is the answer.
Beta function. In mathematics, the beta function, also called the Euler integral of the first kind, is a special function that is closely related to the gamma function and to binomial coefficients. It is defined by the integral b times x y is equal to integral of 1, 0, t x minus 1 times 1 minus t y minus 1 dt. For complex numbers, inputs x, y such that Re x is greater than 0, Re y is greater than 0. The beta function was studied by Euler and Legendre and was given its name by Jacques Binet. Its symbol B is a Greek capital beta. The beta function is symmetric, meaning that beta xy is equal to beta yx for all inputs x and y. A key property of the beta function is its close relationship to the gamma function. One has that beta xy is equal to gamma of x, gamma of y over gamma of x plus y. The beta function is also closely related to binomial coefficients. When x or y by symmetry is a positive integer, it follows from the definition of the gamma function that beta xy is equal to x minus 1 times y minus 1 over x plus y minus 1 equals x plus y over xy, or x plus y x. So beta function xy. This is the problem that we're going to solve later. First things first, let's write the formula. Beta x y is equal to 2 integral of pi over 2 0 sine 2x minus 1 theta times cosine 2y minus 1 theta d theta. So we will now substitute the value on this formula, which is equal to 2 integral of pi over 2 0 sine 7 over 2 times 2 minus 1 theta times cosine d over 2 times 2 minus 1 theta d theta. Since the over 2 and 2 here are similar, we can cancel it out. Same as in this case. We will, after the cancellation, this is the answer that we will get, which is equal to 2 integral of pi over 2 0 sine 6 theta times cosine 4 theta d theta. So we will now express this using gamma function. Since 2 integral of pi over 2 0 sine x theta times cosine y theta d theta is equal to gamma of x, gamma of y over gamma of x plus gamma of y. The value of x and y are 6 and 4. We got this from this equation. So we will now start. Gamma x plus 1, gamma y plus 1 over 2 gamma x plus y plus 2 over 2. This will be equal to 2 gamma of 6 plus 1 over 2, gamma of 4 plus 1 over 2, over 2 gamma of 6 plus 4 plus 2 over 2. From this, we will get this answer, which is gamma of 7 over 2, 6 plus 1, 7, 10 over 2, and gamma of 5 over 2, 4 plus 1 is equal to 4 plus 1 over 2, which is equal to 5 over 2. And in this one, gamma of 6. Will now be factorial using this formula, which is n is equal to n minus 1. So we will now factor 7 over 2 and 5 over 2. I already factored it out. It is equal to 5 over 2 times 3 over 2 times 1 over 2 times gamma of pi for the 7 over 2 and for the 5 over 2. 3 over 2 times 1 over 2 times pi times gamma of pi equal to factorial of this 5 times 4 times 3 times 2 times 1. So we can use cancellation. I cancelled 5 over 2 for 5, 3 over 2 for 3, 1 over 2 for 1. So after cancellation, this is what's left out. 3 over 2 times 1 over 2 times gamma of pi over 4 times 2. From this, we can now get the final answer. The final answer is 3 pi over 32. That's all. Thank you.